Okay, welcome to this video. This is the third series of chemical kinetics. And under this video, we shall discuss initial rate method. Initial rate method on how to determine order of reaction. And we shall look at what? Zero order. In this video, these are the two things we shall discuss. And before I continue, you have to subscribe. Please subscribe to our YouTube channel. If you have, if this is your first time, you have to subscribe. Please subscribe to our YouTube channel. Please press the word subscribe button and comment, share with your friends, and like this our video. Please subscribe. Press your subscribe button below. Please. Thank you. Okay, let us look at it. Before I continue this, we have ways in which we determine order of reaction. We have four ways in which we determine order of reaction. We have initial rate method. We have integrated rate law method. We have half-life method, and we have graphical method on how to determine order of reaction. But in this video, we are going to take this first one on how to determine order of reaction together with what? Zero order. Then under zero order, I will talk on what? Integrated rate law of zero order. I will talk on what? Half-life of what? Zero order. Then I will give you the graph of what? Zero order, under zero order. But before I go into zero order, I first talk on what? Initial rate method. Initial rate method. I will talk on what? Initial rate method. Then let's move, class. Let's go. Initial rate method. Initial rate method. Initial rate method. Initial rate method on how to determine order of reaction. And before I move, I want you to understand this. When you have rate law expression, rate law equation, when you have something like this, don't forget, this equation is known as what? It's known as rate law equation. This is rate of reaction. K is what? Rate constant. A is what? Concentration of reactant A. B is what? Concentration of reactant B. X is what? The order of reaction with respect to A. Y is what? Order of reaction with respect to B. For this chemical equation, when you have A plus B to give what? Product. To give product. When you have this what? Reaction. The rate law expression is given as this. R is what? Rate of reaction. K is what? Rate constant. A is what? Concentration of reactant A. B is concentration of reactant B. S is order of reaction with respect to A. Y is order of reaction with respect to what? B. Then the overall order of reaction, that is N, equal to what? S plus Y. I told you that. And don't forget, I told you K can also be called what? Specific rate reaction. Specific rate reaction. When can we call K specific rate reaction? When all the species in rate law equation, all the species in rate law equation, if their concentration is unity, that means K will be known as a specific rate reaction. K will be called specific rate reaction. If the concentration of all the species in rate law equation, for example, A, concentration of A equal to concentration of B equal to unity. When you have concentration of A and concentration of B to be unity, to be equal to 1, That means K will be what? Specific rate of reaction or specific reaction rate. It will be a specific reaction rate or specific rate of reaction. K is specific rate of reaction. When all the species, when the concentration of all the species in a rate law expression is what? Units. Take note. Let us move. Please, let us move. Then before we move, I want you to know this. When you have zero order, you have R equal to what? K. Concentration of A raised to power 0. This is zero order. That means order of what? Concentration of reactant A is what? 0. 0 is what? Order of reaction with respect to what? A. The order of reaction with respect to A for this reactant is what? 0. That means from here you have R equal to K. Because it's raised to power 0, anything raised to power 0 is 1. That means 1. Then from here you have R equal to what? K. What does this mean? Take note of this. That means under zero order, rate of reaction does not depend on what? Concentration. Under zero order. That means if you increase the concentration, it doesn't affect what? Rate of reaction. That's the meaning. Under zero order. If you can see, there's no what? Concentration here. There's no concentration. Why? Because it is zero order. The concentration is what? The concentration of A is raised to power what? 0. There's no concentration. That means increase in concentration in zero order does not affect the rate of what? Reaction. If you increase the concentration by 2, if you double the concentration of A, the reactant A, if you double or triple the concentration of reactant A in zero order, it does not affect what? Rate of reaction. Look at this. First order. First order. Please, I want to bring out something from here. I want you to watch. That's why I'm giving you this. R equal to what? K. A raised to power 1. This is first order. That means in first order, rate of reaction depends on what? Concentration. What is the dependency? They are directly proportional to each other. In first order, rate of reaction depends on concentration. That means in first order, if you double what? Concentration, take note of this. You can pause the video and write it down. If you double the concentration under first order, rate of reaction will increase 2 times. Take note. Under first order, if you double the concentration, the rate of reaction to be what? Double. Will increase what? 2 times. Take note. Please, I want you to take note of those things. We have second order. Second order. Please, I want you to follow me. When you have R equal to what? K, concentration of A raised to power 2. Take note of this. In second order, second order also depends on concentration. The second order, the rate of reaction depends on what? Concentration. The rate of reaction is directly proportional to the square of concentration in second order. The rate of reaction is directly proportional to the square of concentration in second order. In first order, the rate of reaction is directly proportional to concentration of A. But in zero order, rate of reaction does not depend on concentration. That's why increase the concentration for zero order, rate of reaction will be what? Affected. For first order, if you double the concentration, rate of reaction will increase 2 times. Take note of that statement. Look at this. For second order, if you double the concentration, the rate of reaction will increase 4 times. Let me know. If you, for this one, double this, rate of reaction increase 4 or 2 times. Take note. Please, this thing is very important. If you double the word, double concentration. This thing means concentration of A. Then under second order, if you double the concentration of A, The rate of reaction increases what? 4 times. 4 times. 4 times. Take note. That is under what? Second order. Under third order. Third order. Third order. When you have R equal to what? K. This is third order. For third order, if you double the concentration, the rate of reaction will increase what? 8 times. We increase what? 8 times. For third order. Please take note of all these things. That means if you double the word concentration, double the concentration of A, this rate of reaction increase what? 8 times. Take note of this. Because I need this thing. There are some questions you will see under initial rate method in which you don't need to calculate. Just look at the initial, look at the table, just pick your answer. Take note of this statement. Take note of this statement. For zero order, it does not depend on concentration. For first order, first order depends on concentration, the rate of reaction is directly proportional to what? Concentration of A. For second order, rate of reaction is directly proportional to what? Square of concentration. For first order, double the concentration, the rate of reaction increases 2 times. Double the concentration here, rate of reaction increases 4 times. Double the concentration here, rate of reaction increases 8 times. Take note. Then if you go to inverse of it, inverse. I told you for this reaction, when you have R equal to K, A raised to power X, B, Y raised to power Y. I told you that X, Y, they can be positive integer, they can be negative what? Value. Take note, and they can be fraction. That means X and Y, they can be in what? Positive value. They can be what? A negative what? Integer. They can be what? In fraction. Take note of that. And overall, N, which is what? X plus Y. This one too can be what? A negative what? Integer, positive integer, or fraction. Take note of that. Take note of that. Then listen, let us go to this. When you have R to be equal to R equal to K, concentration of A raised to power minus 1. Do you know the meaning of this? Do you know the meaning of this? The meaning of this is just inverse of this. It's inverse of this. When you see, this one is raised to power minus 1, inverse of this. When you double the concentration here for first order, rate of reaction increases 2 times. For this one, when you double the concentration, the rate of reaction will decrease 2 times. Take note of that statement. That is, order of the reaction is what? Minus 1. When you double the concentration, the rate of reaction decreases 2 times. When you have this one, R equal to what? K, A raised to power minus 2. It's an inverse of this. Inverse of this. For this one, second order, when you double the concentration, the rate of reaction increases 4 times. But for this, when you double the concentration, the rate of reaction will decrease 4 times. Take note of that. It's an inverse. Decrease 4 times. Look at this one. Please, I hope you are following. R equal to what? K, A raised to power minus 3. In this case, when you double the word concentration, when you double the concentration, what happens for third order? When you double the concentration, the rate of reaction increases what? 8 times. But for this one, when you double the concentration, the rate of reaction will decrease 8 times. This one, when you double the concentration for the third order, rate of reaction increases 8 times. But for the inverse, when you double the concentration, the rate of reaction will decrease 8 times. Let me assume you have this. What happened to this? In this case, this one, when you double the concentration, the rate of reaction will decrease 16 times. Take note of that. When you double the concentration, the rate of reaction will decrease what? 16 what? Times. In this case, it's an inverse. Please take note of all those stuff. Please take note. I hope, please, you can pause the video and write them out because we need them in calculation for shortcut. For shortcut. for shortcut. For shortcut. Okay, let's move. Let's move. Okay. Let's move. Let's go to the first question under initial rate method on how to determine order of reaction. Initial rate method on how to determine order of reaction. For example, question 1, when you have initial concentration of A, you have initial concentration of B is given what? Mole per liter, mole per liter. Then we have initial rate of reaction. Initial rate of reaction is given in what? The unit mole per liter per second. In this case, let us, you have, for the first experiment, you have 0.1, you have 0.1, 0.2. You have that. You have 0.1, 0.1, 0.2. Let me put 0.2 here, 0.1 here. Then you have 2 times 10 raised to power minus 3. You have 4 times 10 raised to power minus 3. You have 1 times 10 raised to power minus 3. Let us look at this. Let me, because I need there to solve, let me reduce my handwriting. Let me reduce my handwriting. We have initial concentration of A. We have initial concentration of B. We have initial rate of reaction. Rate of reaction. This one is mole per liter per second. This one is given in mole per liter. This one also is given in what? Mole per liter. You have this 0.1, 0.2, 0.1. You have 0.1, 0.1, 0.2. You have 2 times 10 raised to power minus 3, 4 times 10 raised to power minus 3, 1 times 10 raised to power minus 3. Okay, this is for the reaction 2A plus B to give product. To give product. Yeah, calculate from the data given above, from the data given above, write number 1. From data given above, Roman figure 1, write rate law expression. Write the rate law expression. Roman figure 2, calculate the overall order of reaction. Calculate overall order of reaction. Roman figure 3, calculate the value of rate constant K, and get the unit of K. Let us look at this question. Let's do this question. I have shortcut for this. You don't need to work. You don't need to calculate anything. From what I explained earlier, you don't need to calculate anything. But before we do that, let us solve. Let us solve before we go to the shortcut. Okay, look at this. These are the 2 reactants according to this reaction. Reactant A and reactant B. This is their what? Rate of reaction. For the first experiment, second experiment, third experiment. And they want you to use it to determine what? The order of reaction. Get the order of reaction of A, get the order of reaction of B, get overall order of reaction, then you can now write the word rate law equation, rate law expression. According to this equation, I have to this word reaction, and we have R equal to rate of reaction. Let me use small r, K into what? A raised to power X, B raised to power what? Y. That is what? The rate law equation. I need to get the value of X and what? Y. Using this word table, I need to get the value of X and Y. For the first experiment, I have the rate is given as what? 2 times 10 equal to K unknown. A is given as what? This is A, concentration of A for the first experiment. That's what can you see? This is initial rate of reaction R for the first experiment. The A, concentration of A is what? 0.1 raised to power X. Then B is what? Times 0.1 raised to power Y. Let me call this equation 1. Let me write all of them out. For second one experiment, the rate of reaction is what? This. We have 4 times 10 raised to power minus 3 equal to K into A is what? 0.2 raised to power X. Then B is what? 0.1 raised to power Y. Let me call this one equation 2. For the third experiment, the R is what? 1 times 10 raised to power minus 3 equal to what? K into 0.1 raised to power what? X. 0.2 raised to power what? Y. Equation what? 3. Then, what can I do? I need to get X and Y. For me to get X, that means I need to eliminate what? Y. For me to get Y, I need to eliminate X. Then first of all, eliminate what? Which one can I eliminate? Let me eliminate what? X. How can I want to eliminate X? If I want to eliminate X, take note. If I want to eliminate X, and X is what? X is what? Order of reaction with respect to what? A. Order of reaction with respect to A. And I want to what? Eliminate what? X to get Y. I want to eliminate X to get Y. And I know X is what? Order of reaction with respect to what? A. That means I will use what? 2 experiments under A that are the same. I will work on 2 experiments under A that are what? That have the same value, that have the same concentration. Which experiment? Experiment 1 and what? Experiment 2. So that I can eliminate what? X to get Y. I will work on what? Experiment 1 and 2 because they have the same value under A, so that I can eliminate what? X to get Y. That means from here, experiment 1 and what? Experiment 3, they have the same value under A, so that I can eliminate X to get Y. I will just say divide equation 3 by equation 1. Equation 1, so that I can eliminate X and get Y. What is equation 3? 1 times 10 raised to power minus 3 equal to what? K into 0.1 raised to power X, 0.2 raised to power what? Y. Then over equation 1, 2 times 10 raised to power minus 3 over K into 0.1 raised to power X, 0.1 raised to power what? Y. What happened? This cancel this. What happened? This cancel this. I have 1 over 2 equal to this one. This one in this one, I will have what? 2 raised to power what? Y. This one is what? 2 raised to power minus Y equal to 2 raised to power what? Y. What happened? 2 cancel 2. What do I have? I have Y equal to what? Minus 1. Y equal to what? Minus 1. Can you see? Y equal to what? Minus 1. I've gotten that. Hope you understand. You can pause it. Y equal to what? Minus 1. I've gotten Y. How can I get what? X. How can I get X? That means for me to get X, I need to eliminate what? Y. And Y is what? Order of reaction with respect to what? B. Order of reaction with respect to B. Order of reaction with respect to what? B. That is order of reaction with respect to what? B. That is Y. It's order of reaction with respect to B. That means for me to eliminate Y now, I need to go under B and use two experiments that are the same. Under B, which experiment are the same? Experiment 1 and experiment 2, they are the same. So that I can eliminate what? Y to get what? X. Isn't it? Let me write it here. Is it okay like this? Is it okay? Yeah. Then for me to do that, that means divide. Is it okay? Divide equation 2 by equation 1. Divide equation 2 by equation 1 so that I can eliminate what? Y and get what? X. What is equation 2? I have 4 times 10 raised to the power minus 3 equal to what? K into 0.2 raised to the power x, 0.1 raised to the power y over 2 times 10 raised to the power minus 3 equal to K 0.1 raised to the power x, 0.1 raised to the power y. From here, K cancel K, this cancel this one cancel this one. What do I have? I have 4 over 2 equal to what? This one I have 0.2 raised to the power x over 0.1 raised to the power x. This one I have 2 equal to this one I have 2 raised to the power x. That means I have s equal to what? 1. S is equal to 1. S equal to 1. S equal to 1. Very simple question. Very simple question. There's a shortcut for this. You don't need to calculate. If it is what? Multi-choice question. You don't need to calculate. I will give you the shortcut. That is that. Then from here, they say write rate law expression. Write rate law expression. What is the rate law expression now? From here, I have R. From here, rate law expression. What is X? X is what? Raised to the power 1. What is Y? Y is what? Minus 1. Raised to the power minus 1. This is my rate law expression. Very simple. Very simple. Very simple. That's my rate law expression. That's my rate law expression. That's my rate law expression. That's my rate law. Do you know the shortcut? If you don't want to calculate, the shortcut is very easy. From what I told you earlier, look at this. Equation experiment 1 and experiment 2 under A is doubled. Experiment 1 and experiment 2 under A is doubled. When concentration of B for experiment 1 and experiment 2 is constant. It must be constant. This one, constant. This one, doubled. Then what happened to their rate of reaction? Also what? Doubled. And what does it mean? I told you when concentration is doubled, rate of reaction increases what? 2 times. When concentration is double, this one increases what? 2 times. It's also double. What kind of order of reaction? First order. That's why this one is doubled. This one increased 2 times. It's also what? Double. Therefore, this one is for first order. That's why. First order. You don't need to calculate. You don't need to calculate. You don't need to calculate. That's shortcut. When it is doubled and rate of reaction is double, that means this one that is double, that causes rate of reaction to be double, this one is what? First order. Okay, let us look at B. Look at this. Under B. Look at B. B. This and this constant. Experiment 1 and experiment 3 constant. Then look at this. Experiment 1 and experiment 3 is what? Doubled. 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 What happened to what? Rate of reaction under experiment 1 and experiment 3 reduces, decreases. This one decreases. Decreases by 2. What did I tell you under that? It will be inverse. Inverse of first order. I told you when you have concentration to be doubled and rate of reaction decreases by 2, that is inverse of first order, which is what? Raised to the power minus 1. You don't need to calculate. You don't need to calculate. How? That means B is doubled. And when B is doubled, when concentration of B is doubled, That means the what? Rate of reaction, it decreases by what? 2. That means inverse of first order. That means B will be what? Order of reaction of B will be what? -1. You don't need to calculate. You don't need to calculate. Please, let's move. That's a shortcut. Let's move. Then the next question, it says, calculate overall order of the reaction. Overall order of reaction. What is overall order of reaction? Overall order of reaction is what? X plus Y. That means from there, N equal to 1 minus what? Plus minus 1. Therefore, N equal to what? 0. That means overall order of this reaction is what? 0. Overall order of this reaction is 0. Overall order of this reaction is 0. Overall order of this reaction is 0. That means, let me write it here. We have overall order of reaction N is what? Overall order of reaction is what? N equal to X plus Y. That's overall order of reaction. Then N equal to, what is X? 1 plus, what is Y? Minus 1. Then 1, we have N equal to what? 1 minus 1, which is what? 0. Overall order of the reaction is what? 0. Then the next question, it says, calculate the value of K. Calculate the value of K. Calculate value of K. Calculate value of K. To calculate value of K, you can use any one of the experiments. Let me use what? The first experiment. Let me use third experiment. You can use any one of the experiments to calculate the value of K. You get the same thing. You have R equal to K into what? A raised to power what? 1. B raised to power minus 1. I'm using the what? The third experiment. What is R? 1 times 10 raised to power minus 3 equal to, we have 1 times 10 raised to power minus 3. 1 times 10 raised to power minus 3 equal to K into concentration of A for the third experiment. Then concentration of B for the third experiment, 0.2 raised to power minus 1. Here are 1 times 10 raised to power minus 3 equal to what? K into what? 0.1 times what? 1 over what? 0.2 raised to power what? 1. What we have what? 0.2 times 1 times 10 raised to power minus 3 equal to what? K into 0.1. What I have 0.2 times 10 raised to power minus 3 equal to what? K 0.1. Then I have 0.2 times 10 raised to power minus 3, 10 raised to power minus 3 over 0.1 equal to K. What happened? 2 times 10 raised to power minus 3 equal to what? K. Then, what is the unit of K? Don't forget the unit of K. I know that the overall order of the reaction is what? 0. Overall order of the reaction is what? 0. Overall order of the reaction is 0. And in the second video, I gave you the formula to calculate what? Unit of K. I told the unit of K depends on what? Order of reaction. Unit of K depends on what? Order of reaction. And the formula for unit of K is what? Mole per liter raised to power n minus n, then per seconds. Then what is n for this question is 0. Therefore the unit of K is what? Mole per liter 1 minus 0 per seconds. Therefore the unit is what? Mole. The unit is what? Mole per liter raised to power 1 per seconds. This is what? Unit. This is unit. Therefore K equal to what? 2 times 10 raised to power minus 3 mole per liter per second. That's the unit of K. That's the unit of K. Please, unit of K. That's it. Or you can write it the way I wrote it. You can write it mole per liter per second. It's the same. That's the unit of K. That's the unit of K. Please take note. Let's go to another question. Question 2. Question 2. You can pause the video. Question 2. Let's go to the second question. Let's go to second question. Let's go to second question. we have initial concentration of A, initial concentration of B, initial rate of reaction. The unit of this, mole per liter, mole per liter. This one, mole per liter per second. 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 Yeah, you have 0.4, 0.4, 0.8. For B, you have 0.2, 0.4, 0.4. Under initial rate, you have 2 times 10 raised to power minus 8. You have 8 times 10 raised to power minus 3. Let me put minus 3. You have 0.5 times 10 raised to power minus 3. Then write rate law expression. Write rate law expression. That's first one. Overall order of the reaction. Find the overall order of reaction. Overall order of the reaction. Then Roman figure 3. Calculate the value of K. Get 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 the value of K. Let us do that. In this case, shortcut. Let's look at the shortcut first. Then before we work it out, let's look at the shortcut. Let's look at the shortcut. This is the data for the reaction. Then the reaction is what? 2A plus B to give a product. This is the data for this reaction during the experiment. That's data for the reaction during what? Okay, let's look at this question. The question says write rate law expression, overall order of reaction, and value of what? K. Let us look at the shortcut. This is the data for this reaction, 2A plus B to give a what? Product when the experiment is being carried out. We have this data. Let us try. We have R. We have, let me start from here. We have R equal to what? K. Concentration of A raised by X. Concentration of B raised by Y. Let us look at the shortcut. If we are going to, after working, if we are going to get the same thing as the shortcut. Let us look at this. Look at this. For concentration of A, experiment 1 and experiment 2, their concentration is what? Constant. Constant. Then look at this. This one is what? Doubled. For experiment, for concentration of B, the experiment 1 and experiment 2 is what? Doubled. Then what happened to the what? Rate of reaction. Rate of reaction increases by what? 4. Increases by what? 4. Increases 4 times. Increases 4 times. 4 times. 4 times. What order of reaction is B? When in for A, initial concentration of A, experiment 1 and experiment 2, they are what? Constant. Then experiment 1, experiment 2 under reactant B, initial concentration of B is doubled. Then rate of reaction, experiment 1 and experiment 2 increases by 4. What order of reaction is what? With B, R. That means for B, R equal to what? K for B will be what? Second order. Go to that thing I gave you first. That when you increase, when you double concentration under second order, when you double concentration, rate of reaction increases 4 times. That is, take note. When you double concentration, rate of reaction increases 4 times under what? Second order. When this one is double, this one increases 4 times. That means the order of reaction of B will be what? Second order. The order of reaction with respect to B will be what? Second order. Then let us go to the what? The order of reaction of A. Let's see. For A, this one and this one are constant. 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 Experiment 4 and experiment 2 and experiment 3, constant. Look at this. Under A, experiment 2 and experiment 3, doubled. You multiply this one by 2, that is double. What happened to this one? What happened? This one decreases 16 times. It decreases 16 times. 0.5 in 8 is what? 16. That means this one decreases 16 times. When this one is double, this one decreases 16 times. When concentration of A is double, this one decreases 16 times. And I told you decreases means what? Inverse. That means for A, the order of reaction will be raised to power minus what? 4. If it is OBJ, you don't need to multi choice question. You don't need to calculate. Therefore, R will be equal to 1 K into 1 A raised to power minus 4, B raised to power 2. That is your answer. The overall order of reaction will be what? Minus 4 plus 2. Overall order of reaction will be 1 minus 2. That's it. You don't need to calculate anything. That is shortcut. Take note of what I wrote first before the class, before this video, before I start at the beginning of this video. The early part of those things I wrote on the board, very important, very, very important, very important. Press the subscribe button. We teach you concept. Notice. This is where we teach you concept. Concept. Please press the subscribe button, share, like, and comment. Please share it with your friend. Please take note. When you do this one under A, you double. Oh, this one is constant under A. Then under B, the first and second is what? Double. Rate of reaction increases by 4. That is second order. Then under A, experiment 2 and 3 is double. Under B, experiment 2 and 3 is constant. Then under initial rate of reaction, experiment 2 and 3 decreases 16 times. That means what? Inverse. Decreases inverse. Please take note. Let us work. Maybe we are going to get the answer. That's it. Very simple. Using the shortcut. I will advise you, please go and work it to verify if you are going to get the same thing. The way I worked the first one, work it to verify. The way I did the first one, work it. Then if they ask you to calculate the unit of K, the unit of K, and you know that what is the formula for unit of K? Mole. The formula for the unit of K is what? Mole per liter raised to power 1 minus n then per seconds. And what is the word? N here is what? Minus 2. That means we have mole L 1 minus 2 per seconds. Therefore, we have mole per liter. This one will give you what? We give you 1 plus 2 per second. Therefore, mole per liter raised to power 3 per second. That's the unit of K for this one. Take note, the unit of K. That's unit of K. That's unit of K. The unit of K is what? That is raised to power 3, liter raised to power minus 3, then per second. That's unit of K. You can go and solve it. Solve for unit of K. Solve for the value of K. Very simple. Solve for the value of K. I've given you the unit of what? K. Please, let's go to another question. Another question. Another question. They never love. They don't know the prophet from such time. Chat. How do you expect them to love Jarastafari in this time? Let's go to another question. Another question where you have this. Another question you have. Another question. Another question you have. 2A plus B give you what? C. Let me put the C. Then, when for this reaction an experiment is carried out, let me give you the value for each of them. This one is what? 0.1, 0.2, 0.1. We have 0.1, 0.1, 0.2. Then we have 1.2 times 10 raised to the power minus 3, 2.4 times 10 raised to the power minus 3. We have 1.2 times 10 raised to the power minus 3. Minus 3. That's the data. That's the data. That's the data. Then the question says, find the rate of appearance of C in the data given above. In the data given above. Option A, you have K, A raised to power 2, B raised to power 1. Option B, we have K, A raised to power 1. You have C, K, A raised to power minus 2, B raised to power minus 1. D, you have K raised to power 1, then B raised to power minus 1. You have this. You have this. That is option. Let us look at this question. Very simple question. We don't need to waste our time. We use the shortcut. Very shortcut. We use this shortcut. They want to calculate what? Find the rate of appearance. That is rate of formation of C. That's what they wanted to find. Rate of formation of C. And don't forget from the first video, rate of formation of C, that means rate of formation for C, we have plus dC dt. That's what they wanted to find. Rate of formation of C. Rate of formation for C. Very simple from this data. Rate of formation for C. What form C is what? When A reacted with B. When rate reacted with what? B. What they want you to do is just to find what? The order of the reaction of A and what? Order of reaction with respect to what? B. That's what they want you to do. Because they are the one reacting to form what? To form C. That's what they want you to do. They are the one reacting. Is reactant A that is reacting with what? B to form C. As A and B are disappearing, C is what? Appearing. That means we want you to find what? Order of reaction with respect to what? A. Order of reaction with respect to what? B. That's what they want you to find. Then let's look at it using the shortcut. When this one is constant, 1 and 2 constant. Let's look at what happens. When it's constant. When this one is what? Doubled. Experiment 1 and 2 doubled. What happened to the rate of reaction? 1 and 2. Also what? Doubled. Increases by what? 2. Doubled. That means A. The order of A will be what? First order. When experiment 1 and 2 under A is doubled, rate of reaction is also what? Doubled. That means order of reaction with respect to A will be what? First order. That means R for A is what? Raised to power 1. First order. Let's look at this. Which one is constant here? 1 and 3. Under A, 1 and 3 constant. Then under B, 1 and 3 is doubled. 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 Then what happened to 1 and 3 under initial rate of reaction? Is what? Constant. Is constant. This one is 1 is constant. What is the meaning of that? When concentration is doubled and rate of reaction is constant, that is zero order. Concentration does not affect rate of reaction under zero order. Take note. Under zero order, concentration does not affect what? Rate of reaction under zero order. When concentration 1 and 3 under A, okay, under A, 1 and 3 is constant. Okay, under B, when concentration of experiment 1 and 2, experiment 1 is doubled, and 2, experiment 1 and 3 is doubled. What happened to rate of reaction under experiment 1 and 3? Constant. Experiment 1 and 3 doubled under D. The rate of reaction is constant. Therefore, what order? Zero order. That means R for B. Order of reaction of B is what? Zero order. Then join the two. R equal to 1. K into A raised to power 1. Then B raised to power 1. 0. Then this one raised to power 0 is what? 1. That means R equal to 1. K A times what? 1. Therefore, R equal to 1. K A. That means which answer? Option B. Very simple. Very simple. Very simple. There's no need to work. Shortcut. Shortcut. You get it? Shortcut. Very shortcut. 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 Please, shortcut. 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 Let me give you this. The last one for today, under this video. The last one. Because I won't be able to do zero order. Because I need to explain so many things. That will be what next video under zero order. Because under zero order, I will talk on what integrated rate law. I will talk on what half-life. I will talk on what lifetime. I will talk on what differential what method. That one we've done it before. Very simple. Then I will talk on what special zero order reaction. Special zero order reaction. We have special zero order reaction. And I will give you all the graph. We shall do some questions. I will talk on that. Because of the time, it's not that much for this video. I don't want to bore you into so many things. I will just give you the last question for today. Okay, look at this question. Look at this question. Look at this question. Look at this question. Please help us to share this video, like this video, please share, like, comment, please. We need you. We need you. We need you. We need you. We need you to do that for us. Okay. According to this reaction, if the rate of disappearance of E increases 16 times. Increases 16 times when the concentration, or let me use 8 times. Let me use 16 times. When the concentration of E is doubled. When the concentration of E is doubled. When the concentration of E is doubled. The order of reaction. The order of reaction is option A, 1, B, 2, C, 3, D, 4. Very simple. You don't need to waste your time. You don't need to waste your time. You don't need to waste your time. I told you, R equal to K A, zero order. When this one is double, it has no effect on rate of reaction. Why? Because under zero order, rate of reaction does not depend on what? Concentration. Under first order, when this one is double, rate of reaction is also what? Doubled. Under second order, when concentration is double, rate of reaction increases 4 times. Under third order, when concentration is doubled, rate of under third order, when concentration is what? Doubled, rate of reaction increases 8 times. Then, when you have this, fourth order, when concentration is what? Doubled, what will happen to rate of reaction? It will increase 16 times. There's no need to work. 16 times. The answer is what? 4. Or if you want to work it out, you can write it. You can say R, according to this equation, that is R equal to what? K E. That means the reactant is what? E. E. They now say, what happened? They want you to find order of this reaction. The question now says, if the rate of disappearance of E increases 16 times, this one increases 16 times. Let me call it 16 and 1. When what? E is doubled. When E is what? Doubled. When E is what? Doubled. You have this. From here, what do we do? Call this one equation 1. Call this one equation what? 2. Then what do we do? Divide equation 1 by what? Divide equation 2 by what? Equation 1. What will you do? 16R1 over R. Or let me call it, no, there's no need to, since 16R over what? R equal to K 2E raised to power what? X over what? K E raised to power what? X. What happened? K cancel K, R cancel R. That's 16 over 1 equal to, this one is what? 2 raised to power X, then E raised to power X over E raised to power what? X. This one cancel this. What do you have? You have 16 equal to what? 2 raised to power X. This one is what? 2 raised to power 4 equal to 2 raised to power X. 2 cancel 2. Therefore, S equal to what? 4. And this money, don't calculate. I've given you that. Please, subscribe. Press subscribe button. Please, we need you. We need you. We need you. We need you. We need you as much as you need us. We need you. Please subscribe, share, comment, send to your friends, and please like this video. Then in the next video, we shall talk on what? Zero order and what? First order. It will be easy for me to what? Take the two together. Zero order and first order. At this moment, let us call it a day. I remain myself, Jama from Neotisa.